We're going to continue to look at the central limit theorem. This is part 3 of our look at the central limit theorem. Now, consider an X distribution, right? That's our original parent distribution with a mean of 53 and a standard deviation of 15. If the specifications of a research project require the standard error of the corresponding X bar distribution to be 2.5, how large of a sample is needed? Well, if you remember, our standard error is just our sigma X bar, which is our sigma divided by the square root of n. So in this case, our sigma is 15 over the square root of n, and this needs to equal 2.5. So what we need to do now is solve for n. So if I multiply both sides by the square root of n, I divide by 2.5 on both sides. This is 6 equals the square root of n. If I square both sides, I get n is 36. So if you were given your standard error and you want to find the sample size, you just use this formula and then solve for n. Let's look at another example, kind of driving this home again. So a pizza restaurant has a mean delivery time of 30 minutes and a standard deviation of 4 minutes. What's the probability the next pizza delivered will take less than 23 minutes? First thing I want you to think about, less than 23 minutes, is what is our variable? We really have 3 now, right? We have z, we have x, and we have x bar. This is x. So now to put that into the calculator, that's going to be normal CDF. It is less than 23, so that's negative 999, 23, 30, and 4. And if I do that, I get 0.04. If we have, what's the probability, get rid of this, that it will take less than 27 for the mean of 20, that is x bar is less than 27. So now that requires us to do something different. That would be negative 999, 927, 30, and now we have 4 divided by the square root of 20. And that is, if we put that in the calculator, we get 0.000398. So once again, you want to decide, are we looking at a single pizza or a single thing that's just x, or are we looking at the mean of a sample, and that is x bar? Now, if you think about these two problems, let's considering the graphs here. If this is our x distribution in red, our mean is 30, our standard deviation is 4. If this in blue is our x bar distribution, you'll notice this is still 30, but our standard error is 4 divided by the square root of 20. And remember, a sampling distribution, an x bar distribution, is based on the sample size. So if we wanted to look at something and say, let's say this is 30, and we pick a number, let's say 29, and we want to say, what's the probability between 29 and 31? Which one has a bigger area? Well, the red is here. the blue would be here. So obviously the blue is bigger in this case. Now, if it was out on the tail, something could be different. But you can get different probabilities here because since our standard deviation is smaller, this is narrower, there's more in the middle. Now, that's when we have the standard deviation. That's when we can put it in our calculator and actually do the calculations if we wanted to there. But let's say we don't have the standard deviation. Suppose the x distribution has a mean of 20 and consider two corresponding x bar distributions. The first distribution, A, has a sample size of 36. B has a sample size of 81. Now, both of our samples are over 30, so it doesn't matter. So first off, what is the mean of these two distributions? Well, we know both of them have an x bar that's the same, which is 20. They have the same mean. Now, if we wanted to graph them, though, and we have two distributions, we have one distribution that is, I will say red is 36, and the other distribution, blue, is the 81. How do we know which is which? Well, that goes to that standard error. We know the bigger the sample size, 81, that means you divide by the square root of n, right? So this one would have sigma over the square root of 36. This would have sigma over the square root of 81. So this is a smaller number, which means the blue is this graph. And the red is this graph, because the standard deviation is smaller, so it's more spread out. So we know our mean is 20, and the question is, for which distribution is the probability x bar less than 18 smaller? So we go here, here is 18, and we have our two areas. Which one? There's the blue. Let me change that to blue. Or the red. Has a smaller value. And I think you can see from out here, the blue gets very skinny. There's a lot more red over here. So which one's smaller? It would be the blue, and that's really messing you up by writing blue in red. It would be the blue is smaller, okay? Because blue has more in the middle, is one way to another way to think about it. Blue has more in the middle, so it has less out in the tails. Now, if we did the same thing, and we had blue is more in the middle, red is a smaller standard deviation, so here, and we had 20 in the middle, and we wanted 18 to 23, and we said, which one in the middle here is smaller? And you can see in the middle, blue has more in the middle. So blue's higher, bigger area, more probability. So which one has a smaller? This would be red. So this is just a great way to understand what's going on here based on the sample size, and we can't do calculations. We can't put this in the calculator to do it because we don't have a standard deviation. Standard deviation doesn't matter. We're still able to kind of figure it out. When you do these, you're going to want some sort of justification. It's going to say explain or, support your answer. All that means is draw this graph. Maybe not that one. It's kind of hard to see. Maybe this one here. And it's easy to see that blue is going to have a bigger area in the middle than red. All right, this is our final day talking about the central limit theorem. Hopefully, we're really understanding what we're doing. Now, before we stop and pass out the homework, let's try one more problem. So we have the problem here. This is on your notes. A few things are covered up here, so we can make sure we do these together. So first off, our two sizes are n is 49 and n is 100. And the second one, which distribution is x bar less than 35 larger? And the second one, for which distribution is 25 to 32 smaller? So go ahead, you can pause the video. You can try these, and then we will come back and we will look at the answers. So you can pause the video right now, try these, and then come back and see how we did. All right, as we come back and look at these, suppose the sample mean is 32, which means our x bar distributions, our mu x bar is the same for both of them. They are both 32. For our graphs, our red graph is going to be 49. Our blue graph is going to be a 100. So because we have a bigger sample, the smaller standard deviation, which means it's narrower in the middle. So for which distribution is x bar less than 35 larger? So if here is 35 and to the left, if you just look at that, you can see to the right, there's more red to the right, which means to the left, there has to be more blue. And then if we look from 32 to 25, is the next one. There is more blue between those. So that is going to be which one is smaller. Blue is, more blue down here, goes below. So blue is the smaller. Sorry, I did that one backwards. I did larger for both of them. The smaller one between those two is also red because you can see there's more on the outside. I did both of these as larger, but the second one was smaller. All right, you are now ready for the homework on the central limit theorem 5.4, part 3.